Hello students, today we are going to discuss osmosis and osmotic pressure. I think all of you know what is osmosis. Osmosis is the flow of solvent from a lower concentration to higher concentration through a semi-permeable membrane. Many of you make mistake, as you know most of the things they flow from high to low, but osmosis is a phenomenon where it flows from low to high of solute concentration. This question was asked this year in the board exams, and many of the students they made mistake in writing this particular part. That is, they have written osmosis is the flow of solvent from higher concentration to lower concentration, and they lost marks. So be very careful. So the process of osmosis occur till both the solution attain the same concentration. So how long a process of osmosis will occur? When till the two solutions attain same concentration. So here we have taken a schematic diagram. You can see we have taken a chamber which is separated by a semi-permeable membrane. In one we have taken concentration A and another concentration B. It may be solution and solvent also. No. So we have assumed that concentration of A is more than concentration of B. So as per the concept of osmosis, from where to where the solvent will flow. And one more thing you have to remember, it is not the solute which flows, it is the solvent only which flows. So since concentration of B is less, solvent from B will move towards A, as you can see in the diagram. So this is called osmosis. Now during osmosis, the solution having higher concentration is known as hypertonic solution. So out here as per the example, chamber A, since it is at higher concentration, it can be termed as hypertonic solution, and the one having lower concentration is called hypotonic solution. So osmosis can also be defined as the flow of solvent from hypotonic to hypertonic till both the solutions attain same concentration, and if the solutions having same concentration, we say it is isotonic. So when two solutions have same concentration, that is concentration of A is equal to concentration of B, then they are called isotonic solutions. No osmosis occur if concentration of A is equal to concentration of B. That is, the process of osmosis stops when the two solutions attain the same concentration. So remember, we are discussing colligative properties. Osmosis is not a colligative property. Now few examples of osmosis let us take. Here you can see we have I have given you few examples. These are commonly used in our day-to-day life. If an eggshell, as you know, the composition of the eggshell is calcium carbonate. If you dip it in sulfuric acid, acetic acid, which you all have at home, that is vinegar, you will see the hard shell dissolves after some time. Okay, and what you will get a thin membrane inside under the hard shell. Now if you keep two such eggs after removing the hard shell, one in concentrated NaCl and another in fresh water, you will see the one in fresh water becomes bigger in size, and the one in sodium chloride solution or any other solution will shrinks, because outside concentration is more than the concentration inside the egg. So this is one example. And it is a common practice that before we cook rice or dal, or even those pulses like chana and all, we soak it overnight. And most of you must have noticed after soaking, their size becomes more. They become bigger in size. So that is also due to osmosis. The water rises in the stem and the roots of the plants also due to osmosis. Of course, this is a combined effect of surface tension, capillary action, and osmosis. The dry grapes, that is the raisins, when you are placing them in water, after a few hours, you can see they swell in size. And okay, the next point, number 5, is very important. Okay, you must have seen when the people fall sick, the patients are given saline, and saline is nothing but sodium chloride solution, which is inserted inside the veins. Okay, we call them intravenous process. So when this saline is injected in your body, through veins, it mixes with the blood. Now you know blood is also considered to be a solution having a very fine membrane which can be considered as semi-permeable membrane. Now if the concentration of sodium chloride which is injected in the blood is not having same osmotic pressure as that of the uh, blood cells, then the blood cells either will shrink or they will um, become swollen and ultimately they will burst. So you have to remember this concentration, you must remember 0.9% NaCl. 0.9% NaCl is isotonic with blood. So whenever a patient has to be given saline, it has to be 0.9%, not more than this, not less than this. You can see, you can go through these lines, what is written here. Glucose or saline solution injected into the blood of the patient is must have concentration nearly equal to that of the blood cell. If the concentration of glucose is more, the blood cell will squeeze due to flow of solvent out of the blood cells. And if the solution concentration of glucose is less, then the flow of water into the blood cell will take place, which may lead to the bursting of the blood cell. So either way it is fatal, a patient will die. So special care should be taken in preparing the saline solution or glucose solution which is injected in the blood of the patients. So here again it's mentioned that what is hypertonic solution? Hypertonic solution, as I said, osmosis is not colligative property. What is colligative property is osmotic pressure. Osmotic pressure was also asked this year in the board exams. So you know, when the solvent is flowing from one region to the other, the region where, that means the higher concentration side, if we apply a pressure, okay, if we apply a pressure this side, we have assumed that Ca is having higher concentration, so we apply pressure so that the flow of solvent from lower concentration to higher concentration just stops. Remember, it should not be more than that, just stops. So whatever pressure we are applying here, which is labeled as pi, that much of pressure is called osmotic pressure. So how do you define osmotic pressure? Osmotic pressure is the minimum pressure, remember, minimum pressure that must be applied on the solution of higher concentration just to prevent, not more than that, is known as osmotic pressure. Just to prevent osmosis is called osmotic pressure. So we have to derive the mathematical relationship for this. So you see, mathematically, pi, which is osmotic pressure, is found to be directly proportional to molarity. This is the first colligative property where the colligative property is proportional to molarity. So far whatever we have discussed, they were proportional to molality, but here it is molarity, and the symbol used out here is C. Of course, when we did numericals earlier, we have used capital M for molarity, but here we are using C. Now to remove the proportionality sign, we have to bring in a constant. So you find here pi is equal to CRT, where R is universal gas constant, as you all know. And since osmosis is done at a particular temperature, there is no temperature difference. So T stands for temperature in Kelvin scale. Now, what is molarity? Molarity is number of moles of solute by volume of solution in liters. So we replace the molarity by NB by V, and we get a relation of osmotic pressure pi equal to NB by V RT. If you rearrange, we get pi V equal to NB RT. It is very similar to your ideal gas equation PV equal to nRT. Now you have to prove that osmotic pressure is a colligative property. So it's written here self-study. Now by this time you already know how to prove something to be colligative property. You have to prove that pi depends only on number of particles and not on their nature. So if you can prove that, then you can prove that it is a colligative property. Now let us derive the mathematical relationship for molar mass of the solute. So we do the same thing. We replace NB by WB by MB. Since N equal to mass by molar mass, we all know. And if we rearrange everything, what we find, pi equal to WB by MB into V. In the numerator we have RT, and if V is taken in ml or cc, then you have to multiply by 1000 to convert it to liters. Okay, so we have pi equal to Wb by Mb RT by V into 1000. So ultimately what we find? Pi is also inversely proportional to molar mass. If you have checked all the colligative properties, they are inversely proportional to molar mass. More the molar mass, less will be the colligative property. Now our next topic is reverse osmosis. In short, we call it RO. Last year, not this year, 2020, question was asked what is RO. Many of the students, they knew it is reverse osmosis, but they didn't know it is called RO. So they have written all weird answers. So what is reverse osmosis? Just now as we said, to prevent osmosis, we apply a pressure on the region of higher concentration. Here what they have done, they have taken solution and solvent. So definitely solvent will have lower concentration than solution. It may be two solutions having different concentration. It may be a solution and a solvent separated by a semi-permeable membrane. Okay. Now when we apply a pressure which is just sufficient to stop the osmosis, we call it osmotic pressure. But by chance, if we apply more pressure than osmotic pressure, then what happens? Then solvent particles from solution or region of higher concentration move towards solvent, okay, or to the region of lower concentration. This phenomenon is called reverse osmosis. Okay. Now what is the use of reverse osmosis? You know, there are many places, coastal places especially, you can see this paragraph. Okay, in coastal areas where water contains dissolved salts, because you know saline water, sea water contains a lot of salt and cannot be used for drinking purposes. So in many such coastal areas, since there is no scarcity of sea water, what people do, they set up reverse osmosis plants. So in reverse osmosis plant, what is what is done, huge tanks are built, okay, and in one chamber fresh water is taken, in another chamber salt water is taken. Salt water means the water from the sea, and from this limb a lot of pressure is applied. The pressure has to be greater than osmotic pressure. Then what happens? From salt solution, water tends to flow towards the region of lower concentration, that is fresh water, and when this tank is full, water can be taken out and can be transported to various houses for drinking purposes. So reverse osmosis play a very important role, especially in coastal areas. But one thing you have to remember, the semi-permeable membrane which is used here, that has to withstand a lot of pressure. So it has to be very strong. You know, you can see semi-permeable membranes are usually like balloons. Okay, natural semi-permeable membranes are animal bladders, parchment papers, but those naturally occurring semi-permeable membranes cannot withstand such high pressure, so they burst at certain point of time. So that is why what is done, man-made or a synthetic semi-permeable membrane is used, which is called cellulose acetate. You will find the name somewhere here. Yeah, it is there. Cellulose acetate is used as a semi-permeable membrane which can withstand a lot of pressure without bursting. So reverse osmosis, in short we call it RO, and nowadays if you see, you must be knowing RO filters are available in the market to purify water. But I don't recommend you to drink RO water, because there will be no mineral in the water, because you know water has dissolved minerals in the water plays a very important role in maintaining our good health. Now if all the minerals are removed from that water, first of all the taste will not be that good, and it will cause lot of deficiencies in our body. So this reverse osmosis was asked last year, osmosis and osmotic pressure was asked this year, so don't know what will be asked next year. Alright, you can see in this paragraph some important points are mentioned in the box. A raw mango placed in concentrated solution loses water due to osmosis and shrivels into pickle. So I don't know if any one of you have seen how people make pickle. Now is the time for raw mangoes. So when you buy raw mango from market, we cut them into small pieces and sprinkle sprinkle salt and put them in the sun. When we sprinkle salt, you will find that the mango becomes watery, because water from the mango tends to come out from lower concentration to higher concentration. And when we keep it in the sun, the water evaporates and ultimately the mango shrinks, and then we can prepare pickle with it. Wilted flowers revive when placed in fresh water. A carrot or radish that has become limp because of water loss into the atmosphere can be placed into water, making it firm once again. Water moves into them due to osmosis. When placed in water containing less than 0.9% NaCl solution, blood cells burst due to gain of water, which we have already mentioned. Okay. People who take a lot of salt or salty food experience water retention in tissue cells and intercellular spaces because of osmosis, and this is a kind of disease, and the name of the disease is edema. Okay, name of the disease is edema. You can see here. So it is always that is why it is always advised that you should not take junk food, you should not take too much of chips and any food which contains lot of salt, even sugary food. Then you tend to become fat. Okay, you become obese. So this is a kind of disease which is called edema. So in this chapter we encountered 3 diseases. If you remember, one was Benz, another was anoxia, and the last one is edema. The preservation of meat, this is also very important. You know, earlier days people didn't have refrigerator at home. So what our forefathers used to do, when they buy a lot of fish or meat from market, they preserve it for longer time by sprinkling salt over it, so that the bacterial growth is prevented. The bacteria which is responsible for spoiling of the food. When you sprinkle salt, what happens? The fluid inside the bacterial body will have lower concentration, and the salt concentration will be outside, will be more. As a result, the bacteria will lose its fluid and shrink and die, and that's how we can prevent rottening of meat or fish. And for fruits also, you can preserve them by dipping them in sugar syrup. I don't know, some of you might have seen that you can get tinned fruits sold in the market. Slices of fruit are sold in the market in tins in sugar syrup, which prevents the fruits from spoiling. So through the process of osmosis, on salting meat or candied fruit loses water. Bacteria on salted meat or candied fruit lose water and shrivel and die. So many questions can be asked from this part. So when you study, please be very careful. You should not miss out any point. Okay. So here we have a simple numerical. 200 cc of an aqueous solution of a protein contains 1.26 gram of protein. The osmotic pressure of such a solution at 300 Kelvin is found to be 2.57 into 10 to the power minus 3 bar. Calculate the molar mass of the protein. So what is given here? This 200 cc is nothing but V, but you have to take care of the unit. Here V is given in cc. So in the final formula you must use 1000. 1.26 is the mass of the protein, that is solute, that is Wv. Then temperature is given 300 Kelvin. Osmotic pressure is given 2.57 into 10 to the power minus 3, and what you need to find out is molar mass of the solute, that is protein, which is represented as Mb. Now you need to know the values of R, which you have been taught last year. There are various values of R depending on the units. So here it is liter atmosphere, so it is, or liter bar, and liter atmosphere doesn't have much difference in the values. Why liter atmosphere you have to choose, or liter bar you have to choose? You see, osmotic pressure is given in the unit bar, and this 200 cc can be converted to liters, and so the R value should be chosen as liter bar per mole per Kelvin. So 0.083. So all the values being known, Mb can be calculated. Here they have used the symbol M2. As I told you, either 1 or 2 is used, or AB is used. B stands for solute, B and 2 stands for solute, A stands for solvent, or 1 stands for solvent. Is that clear? So once you solve, as you know, proteins, they are macromolecules, they have very high molar masses. So you can see this particular protein has 61,022 grams per mole as the molar mass. So this is one of the numericals. The next one is question number 2.12. Calculate the osmotic pressure. So we have to find out pi in Pascal. So here they have specified that the unit of pi should be Pascal. By a solution prepared by dissolving 1.0 grams. So 1.0 gram is what? 1.0 gram of polymer. So 1.0 is WB of molar mass 1,85,000. So MB is 1,85,000 in 450 ml. So this is V in 37 degrees Celsius. Please take care. Here temperature is given in Celsius scale. So you have to convert it to Kelvin. Now then what is the value of R you are going to use? You can use the value of R as before, and after that you can convert it to Pascal. You can find out what is the conversion factor for atmosphere to Pascal or bar to Pascal, or if you remember the value of R in Pascal unit, then you can use straightway that also. So please work it out and send me after solving the problem. Thank you.